Hi, I'm Chris Anderson at the EE Web Tech Lab, and today I'm looking at the OM13320 Development Kit from NXP. The OM13320 is an I2C development kit that comes with a number of target devices for exploring the I2C-Bus. For those unfamiliar, I2C is a communications bus, and it requires only 2 signal lines. The protocol allows you to address individual ICs. It's been adopted by a number of manufacturers, and the bus is easy to use and makes your designs more efficient. The kit is centered around the OM13320 development board. There are 2 OM13320 GPIO targets, an OM13399 bridge board. There's also an OM13398 bus buffer board. We also have an OM13396 board, which is not normally included with the kit. The kit also includes a hardware pack with jumpers and standoffs for assembling your kit. Let's take a look at the hardware. The LPC1343 is an ARM Cortex-M3 based microcontroller. It integrates all the communications, including the I2C supporting FM Plus mode. The PCA9665 is an FM Plus parallel bus to I2C-Bus controller with a 68-byte buffer. The PCA9955 is a 16-channel LED driver with dimming and blinking control of RBGA LEDs. There are 2 PCA9672 8-bit port expanders, and those are addressable with up to 16 devices per I2C bus. They have an interrupt output to indicate data has changed on their inputs, so you don't need to be constantly pulling them with your microcontroller. Moving over to the OM13396 board, the PCAL6416A is a 16-bit port expander with up to 2 devices per I2C bus. It also has the interrupt output to indicate data has changed. It also has dual supply voltages, so you can have one supply on your I2C controller side, and you can have another on the input-output port side, so it allows for integrated voltage translation. To get started with this demo, you'll need to launch the NXP FM Plus software. It should recognize your device, and you'll click Go to Device Selection. And again, we're going to select the PCL6416A I/O expander. Start device evaluation. And now it brings you up to the configuration tab for that device. So everything on here now is pertinent to the 6416A. First thing we should do is test the slave address. Make sure that the microcontroller actually sees the device, and it does. You can scroll through here and see all the different settings that are available. As mentioned before, they have the Agile I/O and all of its configuration settings on here. But to start, I'm going to change all of the port 0 I/Os to outputs. And I can click through all of these switches, or I can simply set this to 00, 0. And you'll see all the LEDs light green. Now if I want to, I can change the outputs to low, and that will change the LEDs to red. And again, I can come up here and just set them all at once and change all the LEDs together. So now let's change all the ports back to, or all the IOs back to inputs, so that we can look at some of the features there. Of course, the LEDs turn off. And if I push a button, you'll see that the input is indicated here that I pushed IO 0. Now sometimes without any pull-up resistors, you can get some noise on here and you can get some random inputs. I'm not seeing that now, but let's go make sure that all of our pull-ups are enabled. You can see right here that they're all disabled. Again, we're working on port 0, so we care about this row. So we'll set those all to high, and that will enable the pull-ups on all of these inputs. And so again, we can come in and we can push the buttons. We'll see that it registers on the inputs. Now, again, to illustrate the latching, if I push this button, which is switch 1, and I let go, you're not going to see that input register here. And that's the point of latching. So let's go enable latching. Again, I'll just turn on latching for all pins.